Hello students, this video lesson is going to be about proportions. Proportions are two equal ratios or rates, which may be represented as two equal fractions. The two equal rates, $20 to 4 hours and $40 to 8 hours, may be represented as a proportion, as two equivalent fractions. What is unique about proportions or any two equal fractions is that the numerator of the first fraction times the denominator of the bottom fraction is equivalent to the product of the numerator of the second fraction times the denominator of the first fraction. In other words, the product of the diagonal values will equal in a proportion. So if I wanted to show this, that these two fractions truly are equivalent, I could go ahead and show that the product of the diagonals really do equal. 20 times 8 is 160, and 40 times 4 is 160. This just confirms that this proportion truly is a proportion, that the fractions are truly equivalent to each other. If the diagonals did not equal, then that would indicate that these two fractions do not truly equal, and it's not a true proportion. So if I'm given two fractions and I'm asked to determine if the below proportions are true or false, I would simply multiply their diagonals to see if they really do equal each other. So in this first one, I'm going to take the 8 times 9, which is 72, and I'm going to take the 24 times 3, which is also 72. Therefore, I can conclude that this truly is a true proportion. Now the second fraction, or pair of fractions, I'm going to do the same thing. I'm going to go ahead and multiply the diagonals, the 9 times the 17, and then I'm going to multiply the 262 times 4, and I'm going to see if they equal. And in this case, they do not equal. Therefore, these two fractions do not equal one another, and they do not represent a true proportion. So now I'd like for you to stop the video and determine whether or not the two pairs of fractions below are equivalent and represent a true proportion. So how did you do? The first one was pretty straightforward. Just put in 15 times 12 and 30 times 6, and you can tell that they truly do equal. The second one is a complex fraction, a fraction within a fraction. And on this one, when I want to, I could plug those into a calculator just as they are. There's usually a fraction key on a calculator. Or if I do this by hand, I would want to rewrite these as improper fractions, at least the mixed fractions. So the 2 and 5/6 times the 8, I would end up getting 17 over 6 times 8. And then the 5 and 2/3 become 17 over 3 times the 4. And then when you have a fraction, you want to reduce before you multiply. And then you can change those back into mixed numbers if you desire. But this truly does indicate that these two fractions are equivalent, and therefore it is a representation of a proportion. If one of the numerators or denominators is unknown within a proportion, it can be found by creating a new equation, the product of the diagonals set equal to each other, and then solved for the unknown value. So if I have x over 15 equals 8 over 5, I can rewrite that as 5x times or equal to 8 times 15. Even though in my numerator is x, you just take the top times the bottom. Whenever you have a number times a letter, you always want to put the number in front. And once it's in that format, then I can go back to my multiplication property of equality and divide both sides by 5, which indicates that x equals 24. So again, on this one, I'm going to take my numerator, my 21.4, times my 4.2, and set it equal to 1.5 times x. And then again, I'm going to divide away my 1.5, which is my coefficient in front of my variable. I'm going to divide it from both sides, and I'm going to get the value of x, which is 59 and 92 hundredths. So I have one more example for you just to show you. I have the mixed number 2 and 2/9 over 3/5 being equivalent to x over 3 and 3/5. Well, I'm going to take the product of the diagonals. So I'm going to take the 2 and 2/9 times the 3 and 3/5, and I'm going to write those as improper fractions. And then I'm going to reduce. 9 goes into 18 2 times, 5 goes into 20 4 times. That just gives me 8. And then I'm going to multiply both sides by the reciprocal of the coefficient in front of the x. The reciprocal of 3/5 is 5/3. And I get 40 over 3. So I could leave it like that, or I could change that 40 over 3 into a mixed number of 13 and 1/3. Okay, I've got 2 practice problems for you to complete. So go ahead and stop the video and solve for the unknown value by the use of proportions. So how'd you do? On this one, we're going to take the 9 times the x equal to 4 times 25, which is going to give me 100. Then I'm going to divide both sides by 9, and I get 100 over 9, or I can change that to a mixed number, 11 and 1/9. And that's the value of my x. On my far right, I'm going to change that 2 and 1/5 to 11 over 5 times 10 equal to 6x. And then I'm going to divide both sides by 6 to get the x by itself, which gives me 11 over 3, or 22 over 6, which reduces down to 11 over 3. And then if I wanted to write that as a mixed number, I could change it to 3 and 2/3. Now, proportions are ideal to use in solving word problems. So if a word problem can be set up as a proportion, then this truth could be utilized. When one creates a proportion from information within a word problem, the two rates being set equal to one another must be comparing the same type of items. Both numerators must have the same type of unit, and both denominators must have the same type of units. So something like miles per gallon must equal a miles per gallon. $1 per hour must equal $1 per hour. Items per guest must equal an item per guest. Pounds per feet must equal pounds per, or I guess that's pounds per square feet must equal pounds per square feet. So they just have to be the same type of units, both in the numerator and both in the denominator. So your basic steps are to define your variable, because it's a word problem. There's an unknown that you're looking for, and you have to represent that unknown by a letter. And then create the proportion, set up the proportion, make sure that the numerators have the same units and the denominators have the same units. Then create a new equation with the product of the diagonals set equal to each other, and then solve for the letter x by dividing, or whatever letter you choose, by dividing away the coefficient in front of the variable. And then once you've got your answer, you want to make sure you clearly answer it with the right appropriate units. So let's give an example. Sam's car can travel 170 miles on 6.2 gallons of gas. How far can it travel on a full tank of 14 gallons of gas? Round to the nearest mile. So I'm comparing miles per gallon, miles per gallon. The first thing I'm going to do is I'm going to represent my variable. And so I'm going to say, let x equal the number of miles Sam's car can drive on a full tank of gas, because that's what I'm looking for. And x is miles. So x is going to be, if I have my first fraction as 170 miles over 6.2 gallons, I'm going to have my second fraction being x miles over 14 gallons, because that's the information it gives me. Now that I've created my proportion, my two equivalent fractions, I simply take the product of their diagonals. 170 times 14 is equal to 6.2x. Now, in order to get my x by itself, I'm going to have to divide away the 6.2, which is going to end up giving me 384. And then I have to clearly state my answer to my question. Sam's car can drive 384 miles on a full tank of gas. So let's look at another word problem. David makes $720 in 10 days. How much does he make in 4 days? So I'm comparing dollars to days. It's specifically asking me for how much does he make. So I'm looking for the money amount. The first thing I'm going to do is I'm going to define my variable. I'm going to let x equal the amount of money David makes in 4 days. So then I'm going to create my proportion. I know he makes $720 in 10 days, which must be equivalent to an X amount of dollars in 4 days. Now that I've got my proportion set up, I can create a new equation by multiplying the product of the diagonals. 720 times 4 is equal to 10x. And then I'm going to divide away my 10 to isolate my variable. And my last thing I'm going to do is clearly state what my answer is. David makes $288 in 4 days. Okay, it's your turn to try. Stop the video and go ahead and solve this word problem by the use of creating a proportion. Okay, so how did you do? The first thing we're going to do is we're going to define our variable. It's asking for find the cost, so we're going to let x equal the cost for 11 lessons. Then I'm going to create my proportion. 25 piano lessons cost $168.75, which is equal to 11 lessons over an unknown cost. Now that I've got my proportion set up properly, I'm going to multiply the diagonals and then isolate my variable. Now, if I would have put the cost on top and the lessons on the bottom, as long as I did it for both fractions, this method would still work. You'll still get the same answer. Be sure to always state your answer clearly. 11 piano lessons would cost $74.25. We are at the end of our discussion board, or at the end of our video lesson, and here are your 3 discussion board problems that are due at the end of this module.